Electromagnetic field theory, vector analysis, introduction. Vector analysis is the branch of mathematics that describes quantities by direction and magnitude. Physical quantities and units. Physical quantity, electromagnetics is related to phenomena and entities can be perceived and measured. Those entities are named physical quantities. Unit, measurement for physical quantities is a kind of comparison by standards. Those standards are called units. Fundamental quantities and units. SI stands for International System of Units. System of the most accepted units is MKSA, meters, kilograms, seconds, amperes system, which is subset of SI. Discrete quantity and field quantity. Discrete quantity, which is for only single point in a medium, does not depend on a reference. For instance, average temperature in a room. Field quantity, which changes in terms of direction and amount in a medium, depends on a reference. Temperature in a room, wind speed around in a region on Earth. Scalars and vectors. Scalar is a quantity can be specified by a single number and its unit. Vector is a quantity can be specified both magnitude and direction. Vector algebra. The sum of vectors u and v is denoted by u plus v. There are two methods to find addition of vectors. 1. Completing the parallelogram. 2. Head-to-tail rule. It can be shown in figure. Addition of vectors has two properties: associative law, commutative law. The similar methods are used for subtraction of vectors, as shown in figure. Multiplication of a vector by scalar can be demonstrated by figure as we can apply commutative law. Even distributive law can be applied for multiplication by scalar of two or more vectors. We can express a vector by using its unit vector as the magnitude of the vector u, unit vector of u. The scalar dot product of two vectors. The scalar product of two vectors is defined as u dot v equals to the magnitude of the vector u times the magnitude of the vector v times cos theta uv. The dot product has two laws: commutative law distributive law. The scalar product gives us some results. If the vectors u and v yields the scalar product of u and v equals to 0, then the vectors are perpendicular, orthogonal. If the vectors yields the magnitude of scalar product of u and v equals to the magnitude of u times the magnitude of v, then the vectors are collinear. Collinear vectors can be parallel to each other by the equation. The scalar product of u and v equals to the magnitude of u times the magnitude of v. It means they have the same direction. Or the collinear vectors can be opposite directions by the equation the scalar product of u and v equals to minus 1 times the magnitude of u times the magnitude of v. So we call those vectors are antiparallel. The vector cross product of two vectors. The result of it is another vector given by two notations. Inverse v is the other symbol for cross product. U cross v equals to the unit vector of normal vector times the magnitude of u times the magnitude of v times sin theta uv. The vector an is specified by right-hand rule. The first vector, the second vector, result. This symbol denotes the vector has direction out of the page or the screen. If the vector v chosen as the first of production, we use right-hand rule as this symbol denotes the vector has direction into the page or screen. As we can see, the last two figures, the vector product of two vectors does not have the commutative law. The cross product obeys only the distributive law as products of three vectors. There are two combinations for it. The scalar triple product, the vector triple product. The scalar triple product, this product has the cyclic property as it can be shown in figure. Then the volume of the parallel pipe is found as the vector triple product. It has only property as